What I'm teaching you is what we think is the most proper way to Cirrus.
St. Paul ground, Cirrus 123 Charlie Delta on the GA ramp. Information Charlie. Request IFR clearance to Madison.
Your IFR clearance should be available to you within 30 minutes prior to your proposed departure time, and will remain available up to 2 hours after your filed estimated time of departure. There are 3 ways to obtain your IFR clearance. The first and recommended option is to contact ATC directly. Reference your airport diagram to determine which frequency is appropriate for obtaining your IFR departure clearance. If a frequency is listed in the heading, it will most likely be available on the ground. By contacting ATC directly, you reduce the chance of errors and reduce the time needed to receive your clearance. The second option is used when you are unable to contact air traffic control directly. In this case, you can receive your clearance by contacting flight service via radio or telephone. Lastly, when the prevailing weather at your departure airport is VMC, you can depart VFR, then once airborne, contact the appropriate approach or center facility to receive your IFR clearance. These pop-up clearances are convenient but should be used cautiously. Your in-flight workload will increase while receiving the clearance, so carefully consider the weather, airspace, and complexities of the departure. If you anticipate a high workload as you depart, try to avoid adding this additional task. Instead, get your clearance while still on the ground. There are 2 types of IFR clearances, a full route clearance and an abbreviated clearance. Let's go back to our Cirrus pilot and listen to the IFR clearance they receive.
Cirrus 123 Charlie Delta, you are cleared to the Dane County Regional Airport as filed. Climb and maintain 4,000, expect 8,010 minutes after departure. Departure frequency 125.45, squawk 4512.
That's an example of an abbreviated clearance, the most common type. In an abbreviated clearance, air traffic control clears you as filed. If it includes a departure procedure, air traffic control is required to state the name and transition of the filed departure procedure, followed by the phrase, then as filed. But don't be fooled by abbreviated clearances. While they're convenient, it's important that you identify situations where an abbreviated clearance should not be accepted, such as when the filed flight plan has been changed prior to departure. If you're ever in doubt, request a full route clearance so you may verify all of the information before accepting it.
Can we make that a full route clearance, please?
Both abbreviated and full route clearances contain the same elements. Let's review the clearance received by Cirrus 123 Charlie Delta. The first common element is your clearance limit. Often this will be your destination airport, however, it may be a fix along the way. Second is the route of flight you must follow to your clearance limit. Cirrus 123 Charlie Delta received an abbreviated clearance and was cleared as filed, so you must reference your flight plan to verify your filed route. Next comes your cleared and expected altitude. If you have been cleared for a departure procedure, you may hear the phrase, climb via the SID. This instructs you to comply with all published altitudes on the departure procedure for which you are cleared. Alternatively, air traffic control may want you to level off at an intermediate altitude along the departure procedure. In this case, ATC will add the phrase, climb via the SID, except maintain, which informs you to follow all published altitudes until reaching the specified level off altitude. The last elements are your departure frequency and your unique transponder code. Your clearance may include a clearance void time, a CVT, which is basically an expiration date for your IFR clearance. Should you experience any unplanned delays and are unable to depart prior to your clearance void time, contact air traffic control or flight service immediately to request a new void time. In the event any information was missed or not understood, It's always better to ask and sort out any questions while on the ground as opposed to in flight when your workload is greater. Don't release your brakes until you fully understand and have verified your ability to comply with your IFR clearance. Approach each IFR departure clearance with your full, undivided attention so that you join the air traffic system in the safest and most expedient manner possible.
What I'm teaching you is what we think is the most proper way to Cirrus.
Departure procedures provide efficient and convenient transitions into busy airspace systems and also ensure clearance from terrain and obstacles that may lurk in the departure path. When a published departure procedure such as an ODP or SID is available for your departure airport, Cirrus recommends that you file it, review it, and expect to fly it. Most charted departure procedures are available in your Cirrus Perspective database and are designed to be loaded and tracked simply and efficiently. At busier airports, you will frequently be expected to fly a SID, a Standard Instrument Departure, to ensure efficient traffic separation in the terminal area. So today, let's say you've planned a flight from St. Paul Downtown Airport, KSTP, to Madison, Wisconsin, KMSN. Before you can load your departure procedure, begin at the Active Flight Plan page on the MFD.
Cirrus 123 Charlie Delta cleared to the Dane County Regional Airport via the Zumbro 6 departure. No dyne transition, then as filed. Climb via the SID, except maintain 3000. Departure frequency 121.2, squawk 4366.
Today you are cleared for the Zumbro 6 departure. So proceed with loading that departure into your flight plan. Remember, all procedures, departure, arrival, and instrument approach procedures are accessed via the Procedure button. After pressing the Procedure button, using the outer large FMS knob, highlight Select Departure, then press Enter. With St. Paul Downtown Airport already loaded into the flight plan, your avionics automatically list available departure procedures for that airport. Highlight this departure and press Enter. Next, select your departure runway. From the ATIS, you know that St. Paul is departing runway 32.
7. ILS runway 32 is in use. Landing and departing runway 32. Advise on initial contact. You have Tango.
Highlight this runway and press Enter. Then select your assigned transition, no dyne,
County Regional Airport via the Zumbro 6 departure. No dyne transition, then as filed. Climb via the
and press
SID, except
Enter. Finally, confirm that you wish to load the departure procedure into your flight plan by pressing Enter. By loading the Zumbro 6 procedure, notice that your flight plan is now populated with new waypoints and corresponding altitudes required to comply with the SID. Take a minute to review the procedure for accuracy. First, review the departure header, which includes the departure airport, selected runway, departure procedure, and transition. If correct, review the added waypoints, verifying each waypoint in sequence with your charted departure procedure. By loading each and every SID into your Cirrus Perspective system, you'll streamline your flight, reduce your workload, and ensure your ability to fly any departure procedure accurately and safely.
What I'm teaching you is what we think is the most proper way to Cirrus.
Entry into the IFR environment is often accompanied by a rapid increase in pilot workload. Conducting a thorough takeoff briefing is essential to verify the aircraft and avionics are properly configured, and it's an opportunity for you to develop your situational awareness in preparation for the increased pace of procedural IFR flying. The IFR takeoff briefing is a slightly expanded version of the VFR takeoff briefing. And like the VFR briefing, the IFR briefing should follow a linear storyline that follows your departure all the way through by verifying the type of takeoff, performance considerations, the initial departure plan, and emergency action considerations. Unique to the IFR takeoff briefing is a departure procedure outline, which is typically a little more complex than a VFR departure. The IFR departure portion of the briefing should include the initial departure heading, initial assigned altitude, both confirmed and bugged on the PFD, and the name of the first fix in the departure and how you intend to get there. For a typical IFR departure example, say you're flying from St. Paul Downtown Airport, KSTP, to Madison, Wisconsin, KMSN, and are assigned the Zumbro 6 departure procedure, Nodyne transition. Holding short of the departure runway and with reference to the calculated performance numbers and departure procedure, it's time to brief the IFR takeoff.
Today I'll be performing a normal takeoff from runway 32 here in St. Paul. My available runway distance is 6,491 feet, and I use 2,000 feet of that to take off to clear a 50-foot obstacle. I've been assigned the Zumbro 6 departure, which requires that I fly a 323 heading, which is bugged on my PFD, until 1,400 feet, and then radar vectors from ATC onto the Zumbro 6 departure somewhere between MSP and the jetted intersection. My initial climbing altitude is 4,000 feet, which is bugged on my PFD. If I have any abnormalities prior to rotation, I'll abort the takeoff. Between rotation and 600 feet, if I have an engine failure, I will land straight ahead, and any engine failure between 600 feet AGL, which is 1,300 feet MSL, and 2,700 feet MSL, I will pull caps immediately. Takeoff briefing complete.
Remember, when it comes to caps planning, especially in actual IMC conditions, the bottom line is that if, during an engine failure or any other critical emergency, you cannot make immediate visual contact with the ground, or if in your judgment all other survivable options have just been exhausted, pull caps immediately, regardless of altitude.
Yeah, caps is available.
During every takeoff, take an extra minute or two to perform a thorough briefing. Completing a thorough takeoff briefing gives you an opportunity to review and pre-visualize your departure plan, greatly increasing your situational awareness and preparing you to effectively address the fast-paced procedural steps required by any IFR takeoff and departure.
For departure 134.7065 launch.
What I'm teaching you is what we think is the most proper way to Cirrus.
Cirrus 123 Charlie Delta, turn left heading 090, runway 14 cleared for takeoff.
During a takeoff and climb in actual IMC conditions, things can happen pretty fast. So it's important that when ATC clears you to depart, you have a concise understanding of how to safely and legally get away from the runway all the way to the en route environment. With your before takeoff checklist complete, holding short of the departure runway, the IFR takeoff gets going with receipt of your takeoff clearance from tower. At a towered airport, your takeoff clearance will typically be coupled with an initial tower-assigned heading, and sometimes even amended climb instructions.
Cirrus 123 Charlie Delta, turn left heading 090, maintain 8,000, runway 14 cleared for takeoff.
Upon receipt of that tower-assigned heading, it's your job to bug the heading as a reminder to make the turn during departure. However, if you've been cleared for a SID, tower may leave it up to the published procedure to specify the route and altitudes.
Cirrus 123 Charlie Delta, Van Nuys Tower, climb via the Hayes 4 departure, runway 34 left, cleared for takeoff.
When you depart from a non-towered airport, Your IFR departure clearance serves as your initial departure plan. If your departure clearance does not specify a specific departure plan, either via a departure procedure or assigned radar vectors, then it's up to you to determine if obstacle avoidance can be maintained visually or if an ODP should be flown. If you can't ensure visual obstruction separation for the duration of the departure, and if an ODP exists for the departure airport,
Salt Lake Center, Cirrus 123 Charlie Delta, holding short of runway 22 in Cody, Wyoming. Number 1 for departure via textual ODP. Request IFR clearance to Duluth.
it's a Cirrus recommendation that all ODPs be flown to ensure obstacle clearance and to aid in organizing your departure path all the way to the en route environment. The initial steps for flying an IFR takeoff are nearly identical to those steps involved with a normal VFR takeoff, but with one key difference. Taking the active runway, as part of the final check, press the toga button on the bottom of the throttle handle. Pressing this button activates the flight director into TO, or takeoff mode. The command bars will orient to a wings level, pitch up attitude of 7 degrees. Takeoff mode is designed to aid in smoothing your transition from the runway to that initial takeoff climb attitude.
Cirrus 123 Charlie Delta, turn left heading 060, runway 9er cleared for takeoff.
Left heading 060, cleared for takeoff, runway 9er, Cirrus 123 Charlie Delta.
Proceed with conducting a normal takeoff and, upon rotation, begin to focus your attention to pitch for those command bars and begin making a mental transition from visual flight to instrument-only flying. Once you've reached a stabilized climb, the flaps have been retracted, and you have climbed through a minimum of 400 feet AGL. Either press Nav on the autopilot panel to track the published departure procedure route, or press Heading to track the assigned ATC vector. Press IAS to set and establish the proper climb speed. At 500 or 600 feet AGL, depending on your SR model, make your CAPS call out.
Yeah, CAPS is available.
From this point, as workload permits, complete the climb checklist and transition to a cruise climb, being careful to ensure a continued adequate climb gradient for the departure. At a non-towered airport, it would be your responsibility to contact the local controlling agency as soon as practical and establish two-way radio communications by reporting your altitude and location from the departure airport.
Minneapolis Center, Cirrus 123 Charlie Delta, airborne off Red Wing approximately 5 miles north of the field, climbing through 3,700.
At a towered airport, sometime early in the climb, ATC will hand you off to departure control or the local center controller. Looking at the Zumbro 6 departure procedure out of St. Paul Downtown Airport, begin flying the procedure using heading mode, as ATC is now responsible for vectoring you on to the departure routing. Eventually, ATC will clear you direct to a fix to join the departure.
Cirrus 123 Charlie Delta, cleared direct JetEt to resume the Zumbro 6 departure.
Or assign a heading to intercept the departure procedure.
Cirrus 123 Charlie Delta, turn right heading 180, join the Zumbro 6 departure.
But in either case, ATC will subsequently state, resume the Zumbro 6 departure, indicating you are to resume the procedure once you rejoin. If during the departure, ATC initiates vectors,
Cirrus 123 Charlie Delta, turn left heading 090, vectors for traffic.
simply update the heading and altitude bugs to comply with the clearance. This often happens when you're overtaking or being overtaken by another aircraft, after which ATC will once again provide guidance back onto the departure procedure and include the phrase, resume the Zumbro 6 departure. As with any flight profile, the key to a successful IFR takeoff and climb is to first focus on pre-visualizing the entire procedural flow. Make the takeoff as normal as possible, but use the guidance provided by the command bars as your initial reference to ensure a smooth and predictable takeoff and initial climb. And remember that flying SIDs and ODPs will remove the guesswork and increase your confidence by providing a departure outline of sorts, allowing you to better organize and anticipate the departure route as you slip into the clouds and your IFR flight gets going.
Cirrus 65 Romeo Juliet. We're still coming up with the weather we have today.
Flying direct is usually the preferred method to get from one airport to another. However, when flying in areas with complex airspace, terrain, and/or high traffic volumes, direct routing may not be available. In these situations, planning to use IFR preferred routes or tower and route control routing will pay dividends later in your flight. Both IFR preferred routes and tower and route control, or TEC routes, can be found using your favorite flight planning app or chart supplement. In most cases, these routes will require you to plan, load, and fly Victor Airways, and loading these highways in the sky is made easier, more efficient, and more accurate by utilizing the Load Airway function in your Cirrus avionics suite. So today, let's say you're flying from Fort Myers Page Field, Kilo Foxtrot Mike Yankee, to Fort Lauderdale Hollywood International Airport, Kilo Foxtrot Lima Lima. When flying between two metro areas, preview the route using your favorite flight planning app or the chart supplement IFR preferred route section to identify if there are any preferred routes established for your departure and destination airports. Referencing these sources, you identify a preferred route and are planning to fly Victor 599, entering at the Lee County VOR, Romeo Sierra Whiskey, and exiting the airway at Newer for vectors onto your approach. Many times, the advantages to flying direct are that it's shorter and faster to fly, not to mention much easier to load. However, the airspace between Fort Myers and Fort Lauderdale is congested, so flying an IFR preferred route is necessary. Although it looks much farther to fly the IFR preferred route, it's actually only 12 nautical miles, or 4 minutes longer when compared to direct. Use of preferred and TEC routing will increase the likelihood of an abbreviated clearance and decrease the potential for rerouting once airborne, potentially saving far more time and hassle than a direct route could have provided. Loading an airway into your Cirrus avionics is just as simple as loading a direct route. To begin, you must have a fix loaded into your flight plan that is associated with the airway and not part of an arrival or approach procedure. Romeo Sierra Whiskey just happens to be the entry waypoint for Victor 599 loaded into the flight plan. Move your quick select box so you can add the airway after the Romeo Sierra Whiskey waypoint. Press the menu key and scroll to select Load Airway. Press Enter. Next, select Victor 599 and press Enter. Airways are displayed with the low altitude airways first, followed by high altitude airways. Now, select your exit waypoint, Newer, and press Enter. Press Enter one more time to load the airway. Review the waypoint sequence, referencing your chart and the waypoint list to ensure the airway was loaded accurately. When satisfied, finish loading your route. In this case, add Hollywood International Airport, Kilo Foxtrot Lima Lima, after Newer. If you'd like to shorten the waypoint list, you can collapse or expand airways at any time by moving the FMS cursor to highlight the waypoint title, then press the menu key and select Collapse or Expand Airway. The Loading Airway feature in your Cirrus avionics makes the old chore of loading airways fix by fix just as convenient and accurate as loading a direct route. Understanding this function allows you to gain efficiency and save time.
we think is the most proper way to Cirrus.
Holding provides a means for you or air traffic control to pause a flight, so to speak, buying a little time for the pilot perhaps, but usually to aid in addressing traffic separation initiatives in congested airspace. Oftentimes this occurs prior to an approach to provide adequate spacing between you and a preceding aircraft, or following a missed approach as you determine your next course of action. Regardless of the reason, holding provides a procedure to delay a flight's progression. Understanding how to properly execute a hold using the avionics installed in your Cirrus will reduce your workload and provide you with heightened situational awareness. The format of your holding clearance depends mostly on whether or not the holding pattern is published. Published holding patterns are found on terminal procedures and in route charts. Alternatively, an unpublished holding pattern is one that doesn't show up on any charts and will require that ATC define the location, orientation, and limits of the pattern. An unpublished holding clearance would include all necessary pattern parameters, including the direction of the holding pattern from the fix, referencing cardinal compass points, the holding fix name, course, and leg length, the direction of turn if non-standard left turns are required, and your expect further clearance time, or EFC.
Cirrus 123 Charlie Delta, hold south of the Duluth VOR on the 180 degree radial. Left-hand turns, 10-mile legs, expect further clearance 1455 Zulu.
When the holding pattern is published, ATC may omit all of the instructions except the holding direction and the statement, as published.
Cirrus 123 Charlie Delta, proceed direct thermal, hold southeast as published.
Most published holding patterns, such as those on an arrival or an instrument approach, can be automatically loaded into your flight plan. For situations where a published hold cannot be automatically loaded or ATC gives you non-published holding instructions, you'll need to build and activate a custom pattern. In that case, with your desired waypoint selected, simply press the Menu button and scroll to Hold at Waypoint, where all custom holding parameters can be input in order to comply with the non-published clearance. So let's say today you're flying Cirrus 123 Charlie Delta into Duluth, Minnesota, and after checking in with approach, they reply with,
Cirrus 123 Charlie Delta, for spacing, proceed direct home of, hold east as published, expect the RNAV GPS runway 27 approach at 1345 Zulu.
It doesn't happen too often that you'll receive a hold just prior to an approach, but there are those times where just the right confluence of traffic or perhaps some issue at the airport itself will necessitate the need for a last-minute hold in the terminal area. Since this holding pattern is published as part of the RNAV GPS runway 27 approach, you can first load the procedure from the Procedures menu. Press the PROC button and select the RNAV GPS 27 LPV approach with the Home of Initial Approach Fix transition. Activate the approach, confirm the flight director is set to NAV, and proceed direct to Home of. Because you are arriving from the southwest, the course reversal, or hold, is automatically added into the waypoint list, indicating that after crossing Home of, your avionics will provide guidance to execute the course reversal using a hold entry in lieu of a procedure turn. When you arrive from a direction that does not require a procedure turn, you'll be asked if you would like to fly the course reversal. Selecting No provides straight-in guidance for the approach. Selecting Yes will again add the hold into the waypoint list, triggering a course reversal. In both situations, to remain in the holding pattern, after crossing Home of, you must suspend automatic waypoint sequencing by pressing the bezel key aligned with Suspend. The Suspend selection will be indicated by the presence of SUSP on the HSI. As you head towards Home of, develop a plan for entering the holding pattern. An entry procedure will be selected automatically by the avionics, but it's good practice to develop your situational awareness by determining your own entry procedure. There are 3 recommended entry procedures: direct, parallel, and teardrop. Based on your position, the teardrop entry will work best. Your flight director and integrated autopilot are capable of entering and executing the holding procedure automatically, but be sure to closely monitor the PFD's status box to verify that the hold is being executed properly at all times. When you are within 3 minutes of the holding fix, begin reducing your speed to the Cirrus recommended holding speed of 120 knots. Maximum holding speeds are established by the FAA to keep you within the protective airspace that surrounds the holding fix. Exceeding them puts you at a risk of unduly minimizing separation from terrain as well as other air traffic. Non-standard holding airspeed restrictions will be depicted with the published holding pattern, such as this charted holding pattern over ditch intersection. Prior to reaching the holding pattern, the navigation status box on your PFD will suggest an entry procedure and heading, along with a countdown to help you anticipate your turn. Based on your position relative to the hold, you can anticipate a teardrop entry. Upon crossing home of, a to from flip occurs on the CDI, indicating you've crossed over the holding fix. While in nav mode, the flight director will instruct a turn to begin the teardrop entry by following the heading recommended in the navigation status bar, which should be approximately 30 degrees from the outbound course. Notify ATC that you are established in the hold.
Good approach, Cirrus 123 Charlie Delta is established in the hold over home of at 4,000.
Remember, at some point after passing the holding fix, but before recrossing the fix on the inbound leg, press the bezel key which corresponds to suspend. As you turn inbound, the track vector can help you determine whether you will undershoot or overshoot your holding course. Once intercepted, track the inbound course towards your holding fix. Prevent wind drift by aligning the track indicator with your holding course. Note the difference between the track indicator and your heading indicator. This is your wind correction. And in a standard timed hold, a good rule of thumb is to multiply this inbound correction by 3 and apply it to the outbound leg's heading, but in the opposite direction. 3 times the inbound correction is meant to account for wind drift on the outbound leg and wind drift during the fix end and outbound end turns. But the good news is that when using RNAV guidance for your hold, the flight director corrects for wind drift automatically. While suspend is displayed, your Cirrus will continue to hold over the selected fix, allowing you to divide your attention to other tasks. Approaching the holding fix, your navigation status bar will again provide turn anticipation and heading instructions for the outbound leg. Use this information, and your flight director, for guidance on the outbound leg. The holding pattern over home of is known as an along track distance or ATD hold. This means you fly outbound to a published distance, in this case 5 nautical miles, before you begin your outbound end turn. As the hold progresses, maintain situational awareness by continually evaluating your positional status using a combination of data gathered from the status box, the HSI's CDI guidance, and the navigational plan view references on your MFD. Continually tweak the throttle settings to maintain 120 knots, and remember to communicate with ATC as necessary to relay any fuel limitations or other pertinent planning information of which ATC should be made aware, or to query the status of any known traffic or weather delays.
Cirrus 123 Charlie Delta, cross home of at 4,000, cleared RNAV runway 27 approach.
You're cleared to exit the hold and commence the approach. Press the bezel key aligned with suspend to resume automatic waypoint sequencing after the current holding pattern is completed. Holding is an essential part of IFR flight. In your Cirrus, it can be mostly automated and effortless so long as you understand the simple steps for selecting a published procedure or for manually building and activating your own custom procedure. In establishing your Cirrus in a holding pattern, taking advantage of automated holding guidance will reduce your single pilot workload, allowing you to focus on some bigger picture considerations like fuel, weather, and your post-holding plans. Airports with high traffic volume, congested airspace, or terrain may have standard terminal arrival procedures, or STARS, which will be available to guide you into the terminal environment. In addition to providing an arrival plan for leaving the en route structure and navigating to your destination, STARS also facilitate the efficient flow of traffic while reducing the need for complex clearances from ATC. These procedures are an essential part of your IFR flight as they tie together the en route and terminal environment, setting you up for a successful approach and landing at your destination airport. There are 3 types of clearances you may receive when assigned a STAR. The first and most common type is when you're cleared for the STAR.
Cirrus 123 Charlie Delta. Proceed direct Winchell, cleared Janny to arrival, Winchell transition.
This clearance allows you to navigate laterally along the STAR. However, it does not allow you to descend or navigate vertically along it. The second clearance you may receive is to descend via.
Cirrus 123 Charlie Delta. Proceed direct Winchell. Descend via the Janny to arrival, Winchell transition.
This authorizes you to navigate laterally and vertically along the STAR. To determine your assigned altitude when you receive a descend via clearance, reference the information boxes published on the arrival chart rather than the normal MEAs. Finally, you may receive clearance to descend via except maintain.
Cirrus 123 Charlie Delta. Proceed direct Winchell. Descend via the Janny to arrival, Winchell transition. Accept maintain 9000.
This clearance is similar to the descend via in that you are authorized to navigate laterally and vertically along the STAR, but you are expected to level off at the intermediate altitude assigned by ATC in that clearance. So you're en route from Louisville to Atlanta's DeKalb Peachtree Airport and have been instructed to proceed direct choo-choo and join the Bunny for arrival choo-choo transition. Program the arrival procedure into your avionics by pressing the PROC key, the procedure key, highlighting Select Arrival, then pressing Enter. Make sure to verify the destination airport, in this case, KPDK. Having verified the correct destination airport, highlight Bunny 4 and select it by pressing Enter. Next, select the choo-choo transition, GQO, Golf Quebec Oscar, and press Enter. After loading an arrival, it's a good idea to brief and cross-reference your charted arrival procedure with the information displayed in your active flight plan. While verifying each waypoint, pay close attention to any altitudes published along the way. Altitude constraints published in the navigation database will auto-fill into your active flight plan. However, expected altitude constraints will not automatically load into your active flight plan. Since it's likely that ATC will assign you an expected altitude, it's a good habit to load these altitude constraints into your active flight plan to enhance your situational awareness. Referencing the Bunny 4 arrival, propeller aircraft are to expect clearance to cross Bunny at 5,000 feet. Even though you haven't received your clearance to descend, you can still load the expected altitude into your flight plan to increase, again, your situational awareness. Nearing the end of the arrival, your transition onto the approach is outlined in the routing section of the arrival chart. In this case, you can expect radar vectors to the final approach course after KD intersection. Standard terminal arrival procedures play a vital role in streamlining the arrival process by decreasing traffic congestion through a predictable traffic flow. Utilizing your avionics to assist you during the arrival procedure will reduce your in-flight workload, providing more time to prepare for a smooth transition into the terminal environment. Your transition, or arrival, from the en route structure into the terminal environment sets the stage, so to speak, for a successful approach and landing at your destination airport. Often you'll receive radar vectors or direct-to navigation into the terminal area. However, when obstacles, terrain, or traffic congestion necessitate a more complex arrival plan, you may be assigned a Standard Terminal Arrival Procedure, or STAR. In either case, the vertical navigation, or VNAV, capabilities of the Garmin avionics installed in your Cirrus give you an edge when transitioning into the terminal area by improving your situational awareness and providing insight into when your descent should begin. To provide vertical navigation, the avionics must be able to reference a predictable lateral GPS path, your active flight plan, your current altitude, and target a defined waypoint with your desired altitude constraint. To predict your lateral path, GPS must be your selected navigation source, and you must be within a predetermined cross-track limit of the projected course. When the cross-track limit is exceeded, such as when deviating around weather, executing a procedure turn, or even receiving radar vectors onto an approach, VNAV will be unavailable as the avionics would no longer have a predictable path to follow. The altitude constraint, really your bottom of descent, can be anything from ATC-assigned crossing restrictions to an expected altitude published on an arrival or instrument approach procedure, or even the field elevation at your destination airport, a handy target when expecting a visual approach. Referencing your GPS course outlined in your active flight plan along with your specified altitude constraint, the avionics will work backwards to calculate a top of descent point, or TOD, at which your vertical navigation begins. So today, let's say you're flying Cirrus 123 Charlie Delta at 11,000 feet from Louisville, Kentucky to the DeKalb Peachtree Airport in Atlanta, Georgia. Earlier in the flight, you received clearance to proceed direct to the Choo-Choo VOR for the Bunny 4 arrival. As you approach the Choo-Choo VOR, you receive the following clearance from air traffic control.
Cirrus 123 Charlie Delta, cross 10 north of Choo-Choo at and maintain 9,000.
Meeting a crossing restriction is a great opportunity to utilize the capabilities of your avionics to operate more efficiently while also reducing your in-flight workload. Begin by using the Along Track Offset, or ATK feature. This feature allows you to create a new waypoint along your current track, either before or after any waypoint already specified in your active flight plan. To create the new ATK waypoint, press the FPL button, the Flight Plan button, to display the active flight plan page. Highlight Golf Quebec Oscar, or Choo-Choo, with the Quick Select box, then press the bezel key aligned with ATK Offset. To assign the Along Track Offset distance, rotate the small inner FMS knob to set how many nautical miles you want to cross before or after the selected waypoint, and press Enter to create a new waypoint, in this case, 10 nautical miles before or north of Choo-Choo. Now, set 9,000 feet MSL as the altitude constraint. Notice that the altitude constraint and its associated waypoint are now entered into the current VNAV profile box, as well as additional information related to your planned descent. The flight path angle, FPA, defaults to 1.7 degrees, typically providing a comfortable vertical speed target. If needed, either the vertical speed target or flight path angle can be modified to increase or decrease the descent rate. Returning to the nav page on your MFD, you will notice a TOD, or top of descent waypoint, is now overlaid onto your flight plan route. This waypoint represents the location where your descent must begin, so you arrive 10 nautical miles north of Choo-Choo at 9,000 feet. One minute prior to the top of descent, you will hear the vertical track voice alert,
vertical track,
accompanied by the TOD within 1 minute message displayed in the navigation status box. If you haven't done so already, this is a great reminder to confirm that you have pressed the VNAV key to arm VPath mode and that your assigned altitude is bugged using the Alt Select knob. This is also when the vertical deviation and required vertical speed indicators appear. Much like the glide slope and glide path indicators, the vertical deviation indicator provides guidance as to whether you are above or below the intended vertical path. When the flight director is used, VPath will turn green to indicate that the flight director has captured the vertical path and is providing you with vertical guidance toward your target altitude. While you descend, the required vertical speed indicator marks the vertical speed required to get from your present altitude to your desired altitude constraint, and it's a great reference to support your vertical deviation indicator. If the altitude set in the selected altitude box is higher than the VNAV target altitude, the flight director will level off at the selected altitude. Alternatively, if the VNAV target altitude is higher than your selected altitude, the flight director will provide guidance to and level off at the VNAV target altitude. Now, this logic holds true except for when you are executing an approach with your flight director in APR mode and either glide path, GP, or glide slope, GS, is active. Taking VNAV one step further, your Garmin avionics can also provide vertical direct-to navigation, instantly creating a vertical path connecting your current position and altitude to your selected altitude constraint. This feature really helps to reduce your workload when the situation dictates an immediate descent.
Cirrus 123 Charlie Delta, descend now to Cross Bunny at 5,000.
Because VNAV Direct-to creates a vertical path from your present position and altitude, it's a good idea to arm VNAV before selecting VNAV Direct-to, as this will provide a smoother transition onto the descent. But in any VNAV scenario, remember that if you are unable to make an initial intercept of the VNAV vertical track, it's still possible to manually re-intercept that vertical path by activating the flight director's vertical speed mode, selecting a target descent rate greater than the rate required by the vertical path, and smoothly re-intercepting that path from above. Anytime you are broken away from your course, say due to the initiation of radar vectors from ATC, vertical navigation will be inaccurate or unavailable due to the loss of a flight path reference. Looking at the Bunny 4 arrival, say you expect radar vectors to final approach after crossing Katy. When being vectored onto an instrument approach, selecting Vector to Final will cancel any VNAV guidance, allowing you to focus on ATC altitude restrictions while transitioning to a published portion of the approach.
Descend and maintain 3,000.
But even though VNAV has been canceled, you may still utilize the selected altitude intercept arc, which can be displayed on your navigation map page to increase your situational awareness during descents made without the assistance of vertical navigation. This arc appears along your current track and indicates where you will arrive geographically at the altitude bugged in the selected altitude window, allowing you to make snap judgments of your descent progress, better informing that on-the-fly descent planning. In case you don't see it displayed, navigate to the Maps Setup menu on the MFD, highlight the selected altitude arc field, and select On. Planning your arrival and descent for an efficient and safe entry into the terminal area is so essential. Becoming familiar with the vertical navigation function of your avionics provides greater accuracy and a significant reduction in workload, which allows you to better divide your attention in preparation for the upcoming approach and landing.
Hi, I'm Brad DeGussamy, a factory instructor at Cirrus headquarters in Duluth, Minnesota. In this lesson, you'll get a thorough overview of instrument approach procedures and best practices as they relate to flying your Cirrus.
approach procedures, regardless of type, usually share many common features and procedural steps, which are based on a series of approach segments. It's a pilot's job to be able to visualize each segment and understand each task that must be accomplished in order to stay mentally ahead of the airplane and to fly the safest approach possible. For information on specific types of approach procedures, reference the other instrument approach videos in this series. In this video, let's work through the procedures required by a Cirrus pilot, which are common in any instrument approach procedure, and break down the different approach segments step by step. Preparation for the instrument approach should begin at the top of descent or at least 20 minutes from the destination airport. Begin by obtaining current weather information at the destination to determine active runways and approaches in use.
GPS approach runway 27 in use.
Then, load the proper approach and transition via either vectors or a published initial approach fix. Loading the approach will add the waypoints of your approach procedure to the end of your flight plan. This places the approach in standby, ready to be activated quickly at a later time. If you are unsure if ATC can provide vectors, load the approach with your desired initial approach fix. Then, if you find that ATC can coordinate vectors, they can be easily selected as you activate the approach. As descent is initiated, immediately complete the descent flow and checklist to configure the airplane.
Altimeter set, cabin heat is good, landing light is on, fuel system checks, mixture is good, and the brake pressure is fantastic. Descent checklist is complete.
Once the descent check is complete and the expected approach has been loaded, display that approach chart using the Show Chart soft key. Brief the approach either by reviewing the plate methodically to yourself or verbally for a crew member to cross-check.
Okay, we're going to do an approach briefing, so we're going to show the chart here. Take a look at our approach chart. We're going to be doing the GPS 27 to Duluth. We have all of our frequencies tuned in here. The final approach course is 270. Minimum altitude at Cirrus, which is our final approach fix, is 3,200. Touchdown zone elevation is 1,421 feet. This will be vectors for the approach. The minimums for the LPV are 1,671 feet, which we have put into our timer ref soft key here, and we've rounded up to 1,680. The minimum visibility is a half statute mile. If we have to go mist, it's climbed to 3,300 direct to UTAG, which we'll be holding. Approach briefing complete.
As you review the approach minimums, press the timer ref soft key on the PFD to enter those minimums. Round it up to the nearest 10 feet. This will add a layer of safety as it will program the avionics to send oral and visual alerts as you approach the minimum altitude.
Minimums.
When ATC clears you direct to the initial approach fix or first vector heading, that's your cue to select the procedure button and activate the approach. Many pilots are confused about what activating the approach actually does, but it is really quite simple. By activating the approach, the GPS will either navigate from present position direct to the initial approach fix and start to sequence through the approach waypoints in your flight plan, or, in the case of a vectored approach, will simply display the final approach course. Transition to the initial approach speed of 120 knots prior to reaching the initial approach fix. As you pass the initial approach fix, you are now on a published portion of the approach. At some point, if they have not done so already, ATC will clear you for the approach.
Cirrus 123 Charlie Delta, cleared for the GPS runway 27 approach.
Hearing the phrase, cleared for the approach, is your cue to arm the autopilot approach mode by pressing the APR button on the autopilot panel. As you turn to establish the inbound course, verify that the correct navigation mode is selected and displayed on the HSI, and that the CDI is set to the final approach course. Next, configure for landing by completing the before landing flow and checklist. Select flaps to 50% upon reaching 2 nautical miles from the final approach fix for an approach without a glide path. For an approach with a glide path, select flaps to 50% when the glide path indicator comes alive.
By selecting flaps to 50%, the airplane will naturally begin to decelerate. Stay ahead of the airplane and plan your power reduction to the particular model that you are flying, so that your final approach speed is 100 knots as you begin your descent for the minimum approach altitude.
Prior to reaching the final approach fix, rotate the altitude select knob to bug the next step down altitude, or MDA. In the case of an approach with a glide path, bug the appropriate missed approach altitude. The altitude oral caution is a good reminder to verify that you have the correct missed approach altitude set.
Altitude.
As you cross the final approach fix or intercept the glide path, descent should be initiated by reducing the power to the approximate values listed on this chart, and by pitching forward smoothly. Adjust power to maintain a constant descent rate, and adjust pitch to maintain the approach speed in order to create a stabilized descent at 100 knots. Altitude callouts should be made at 1,000
feet to minimums,
500
feet to minimums,
and 100 feet from minimum altitude,
or 100 feet to minimums.
If flying an approach without a glide path, upon reaching the MDA, smoothly add power to maintain the MDA at 100 knots until reaching the missed approach point or initiating a final descent to land. After leveling off at the MDA, bug the appropriate missed approach altitude.
Remember, you may only descend from the MDA or DA when you have all the visual descent criteria. Okay, we got the runway environment in sight. If all these conditions are met, disconnect the autopilot and transition to a normal visual landing. If these conditions are not met, immediately execute a missed approach.
Minimums.
All right, we're at minimums. Runway environment's not sight, we're going missed.
For more information on flying a safe, efficient missed approach procedure, reference the missed approaches video in this series. Focus on flying and maintaining a stabilized approach, and ask yourself, is my airplane at the proper airspeed, following the correct flight path, and in the proper configuration with the appropriate power setting? Is the descent angle and rate normal? Can I continue the approach with only minor corrections of pitch and power to maintain airspeed and glide path? Will plus or minus 5 degrees of correction be enough to maintain lateral and vertical navigation targets? If the answer to any of these questions is no, and you find yourself consistently outside the stabilized approach tolerances, having to make major corrections, then a missed approach should be executed immediately.
I'm gonna go missed approach.
As you transition to land during an instrument approach, select flaps to 100% if you make visual contact with the runway prior to reaching 500 feet AGL. Selecting flaps to 100% at altitudes lower than 500 feet can complicate the visual transition.
500.
All right, below 500 feet, we're gonna commit to 50% flaps. trying to get the runway environment in sight. We have it in sight. I'm going to go ahead and disengage the autopilot.
A last-minute configuration change can destabilize your approach and may require significant flight control adjustments in close proximity to the ground and runway. If you make visual contact with the runway after 500 feet, it is recommended to simply maintain flaps at 50% and continue to a normal visual landing. And any time you land with flaps less than 100%, be sure to plan for a longer landing distance.
Make it your goal to master the procedures required for any type of instrument approach. Your Cirrus is equipped with the latest technology designed to reduce your workload and provide you with superior situational awareness, allowing for a safe descent and landing under IFR. The key, however, is for you to practice these procedures to maintain proficiency with that high-tech equipment so that you are always ahead of the airplane and so that every instrument approach is a fun and efficient, but overall safe experience.
Hi, I'm Keith Smith, a flight training quality specialist here at Cirrus. In this lesson, you'll learn how to shoot a VOR approach in your Cirrus. If you think that the idea of a VOR approach sounds a little, well, old-fashioned, you're kind of right. However, while your Cirrus Perspective system has the ability to overlay GPS guidance onto just about any instrument approach, there are still plenty of VOR-only approaches which will require that you fly the final approach course using the VOR transmitter for primary guidance. As the IFR system continues to rely more exclusively on GPS, the VOR's role as a navigation aid will continue to diminish. Still, in the future, many airports will maintain VOR approaches to serve as an alternate or backup approach. Luckily, if your onboard GPS equipment ever failed or the GPS satellite network became severely degraded, your Cirrus can still fly a VOR approach using only the VOR receiver. So it's imperative that you practice the VOR approach and feel comfortable flying it in its many configurations. After all, a VOR approach requires the pilot to use procedures and techniques which are common among all non-precision approaches. So let's dive into those procedures and review them step by step. As with most other approach procedures, a VOR approach can be flown as a full procedure, utilizing some type of course reversal or with ATC vectors onto the final approach course. In this example, we'll look at the VOR approach for runway 3 in Duluth, Minnesota, and fly the approach as a full procedure using the 7 DME arc. As you approach the airport, press the procedure key to load the approach into your flight plan via the Maytech initial approach fix. At some point, ATC will either clear you direct to that fix or could possibly provide vectors to intercept the arc. Say you hear a clearance like,
Cirrus 123 Charlie Delta, maintain present heading, intercept the 7 DME arc, and advise when established on the arc.
If you simply activate the approach, by default, the GPS will send you direct to the initial approach fix. But to follow the ATC instructions, you must hold your present heading to intercept the arc. So instead, from the flight plan page, select the arc itself by highlighting the DME arc in the flight plan and activate it by pressing the active leg soft key. The arc will now be your active leg as indicated by the magenta color. As you proceed to the arc, arm GPS mode by pressing the nav button on the autopilot so the airplane will turn to intercept the arc at the appropriate time. Complete the descent checklist and brief the approach. During the briefing,
pay special attention to verify that the correct VOR frequency is tuned and identified into NAV1.
Flying the ARC is as simple as keeping the CDI centered to track the curved GPS path. This is great practice because in the future, as RNP approaches become more common, GPS navigation will evolve to include many more curved track approach segments, just like this DME ARC. Continue flying the ARC. At some point, ATC will clear you for the approach.
Cirrus 123 Charlie Delta, cleared VOR runway 3 approach.
Using GPS turn anticipation, transition from the ARC to establish the final approach course. Once established inbound, using the CDI soft key, switch the primary nav source from GPS to the VOR green needles. Prior to reaching the final approach fix, if you fail to switch the nav source, a select nav message advisory will remind you to make the switch. Notice that when manually switching the nav source, the autopilot will transition out of nav mode, causing it to revert to its default lateral roll mode. This transition will be indicated by a flashing yellow highlight around GPS in the autopilot status box, followed by a green roll annunciation. Therefore, you must press the APR button on the autopilot panel to activate VOR approach mode. This will provide VOR tracking at an increased level of sensitivity. Continue to track the VOR course inbound, descend as necessary, and complete the before landing checklist. Once you are established at your correct inbound altitude to the final approach fix, bug the next step down or MDA. 2 miles from the final approach fix, select flaps to 50% to begin slowing to the final approach speed of 100 knots. If the final approach fix is an off-airport VOR, as you pass through the cone of confusion over the VOR, the autopilot won't attempt to chase a possibly erratic needle. Instead, the autopilot will fly a smooth and straight transition across the zone and reestablish the approach course on the other side. As the to from pointer flips on the HSI, indicating you have crossed the final approach fix, initiate a descent to the step down or MDA by reducing power to the values listed for your airplane.
If hand flying, pitch and power should be smoothly manipulated to maintain 100 knots and a descent rate between 600 and 1,000 feet per minute.
Reference the selected altitude arc to determine if your current descent rate is sufficient. As you descend, make altitude callouts at 1,000
feet to minimums,
500
feet to minimums,
and 100 feet
to minimums
above minimums.
Minimums.
The level off at each step down or at the MDA should also happen smoothly and deliberately by leading the altitude with a smooth increase in power to maintain airspeed and to avoid sinking below the altitude. Once the autopilot captures your current altitude, immediately bug the next minimum altitude. Upon leveling off at the MDA, bug the appropriate missed approach altitude and adjust your scan to occasionally glance forward through the windscreen to attempt to establish visual contact with the runway.
If, prior to the missed approach point, you meet the required criteria for further descent, reduce power to leave the MDA. Establish a stabilized descent using visual glide path aids such as a VASI or PAPI and make a normal visual landing. If upon arriving at the missed approach point or visual descent point you don't meet the criteria to descend below the MDA, initiate the missed approach procedure. Pilots need to master the VOR approach in order to be prepared for every IFR scenario. Today, each Cirrus pilot flies on the cutting edge of aviation technology. This advanced technology prepares pilots to be competent and confident utilizing the next generation of digital and satellite-based systems. Equally so, a Cirrus pilot must be prepared to fly an approach using alternate means of navigation, such as a VOR. In your Cirrus, 99% of the time you'll fly a VOR approach using GPS guidance initially, then switching to VOR green needles to fly the final approach course. However, your Cirrus has the capability of flying an entire VOR approach using only green needles. And it's possible that you may find yourself in such a situation, descending to an airport where using a little bit of yesterday's technology is your only option to cut through the clouds and reach your destination safely.
In aviation, GPS represents the absolute cutting edge of navigation technology, and it can be an instrument pilot's best friend. Hi, I'm Brad DeGussamy, a Cirrus factory instructor. In this lesson, you'll learn how to employ that very technology to enable you to fly all kinds of GPS approaches in your Cirrus.
In aviation, the GPS approach is the most precise use of the entire GPS system and is rapidly replacing ground-based on-airport approach aids, such as VOR and ILS systems. Your Cirrus is equipped with some of the most cutting-edge technology currently available, designed to capitalize on the benefits of the worldwide GPS satellite network. In this video, we'll focus on the instrument approach principles which are unique to the GPS approach. Let's begin by discussing the tech side of things and take the GPS approach step by step. SBAS stands for Satellite-Based Augmentation System. SBAS is a broad term encompassing several specific satellite augmentation systems installed around the world, such as WAAS, EGNOS, and MSAS. All of these systems utilize some network of ground-based reference stations which monitor GPS satellite signals to evaluate satellite health and integrity, as well as correct for small GPS signal errors. The signal correction is then relayed from the ground station to a network of geostationary satellites, which further relay the signal to the SBAS-capable receiver in your airplane. As the Cirrus pilot, this corrected and refined GPS signal gives a much more accurate position solution and allows you to perform GPS approaches with vertical guidance. These approaches are safer and more stabilized as compared to traditional dive and drive methods utilized for approaches without vertical guidance. To safely fly GPS approaches with your Cirrus Perspective system, you'll need to be able to differentiate between GPS approach types. GPS minimums can be separated into two categories: those with approved vertical guidance and those without approved vertical guidance. Localizer performance with vertical guidance, or LPV, will typically offer the lowest minimums utilizing a GPS-generated glide path. LNAV-VNAV minimums are also based on a GPS-generated glide path, but are usually subject to relatively higher minimums, as these approaches are based off of less stringent obstacle clearance tolerances. On the approach chart, both minima are listed as a decision altitude, or DA. LP and LNAV minima are listed as minimum descent altitudes, or MDAs, as they do not utilize any vertical guidance.
It's your job to understand the different kinds of approach minimums, and for you to identify which one of those approach minimums applies to you prior to flight. The minimums for the LPV are 1,671 feet.
As you approach the destination airport, in this case Duluth International, the ATIS is broadcasting RNAV GPS runway 27 in use. Press the procedure key to locate the correct approach to be loaded. A GPS designation to the right of the approach name indicates the procedure can be flown using only GPS as a primary navigation source. Further to the right, the GPS approach type is listed, in this case LPV, to let you know what minimums to expect based on your current GPS capabilities. The approach can either be loaded as a full procedure via a normal initial approach fix transition, in this case plane, or it can be loaded as a vector approach simply by selecting vectors. Now, complete the descent checklist, perform a proper approach briefing, and remember to pay special attention to ensure that you have selected the correct approach minimums. When ATC clears you to the initial approach fix, press the procedure button again and select Activate Approach to proceed direct to the initial approach fix. If ATC issues vectors, press the procedure button and activate vectors to final. During a full approach, GPS steering guidance will help you progress efficiently onto the final approach course. GPS waypoints sequence automatically, while turn anticipation is provided to smoothly guide you from one leg to the next. Turn anticipation will be enunciated on the PFD 10 seconds prior to crossing the fix by providing a waypoint alert and a flashing turn advisory, which allows you to initiate a timely turn at approximately standard rate. When you hear the phrase "cleared for the approach" from ATC, that's your cue to arm the GPS approach mode on the autopilot by pressing the APR button. This will also arm the glide path for approaches with glide paths. As you make a final turn and intercept the inbound course, confirm that the GPS approach type you had planned is enunciated on the HSI, and complete the before landing checklist. If the enunciated approach is different than the one you had planned, adjust the approach minimums to reflect the new approach type. As you continue inbound, automatic CDI scaling will normally begin within 2 miles of the final approach fix, and will constantly increase CDI sensitivity to values determined by the type of GPS approach being flown. When flying a procedure with a glide path, such as an LPV or LNAV VNAV, fly the final approach segment just like you would fly a traditional precision approach, such as an ILS. As you progress closer and closer to the runway, the lateral course and the vertical glide path will become more and more sensitive in an angular fashion, just like a traditional localizer and glide slope. Outside of Cirrus, as soon as the glide path comes alive, select flaps to 50% to begin slowing to the final approach speed of 100 knots, and bug the missed approach altitude. fly the final approach segment using the proper precision approach technique as described in the ILS approaches video in this series. Upon reaching the DA, if you meet the requirements for descending further, disconnect the autopilot and proceed to land. If you do not meet those requirements, initiate a missed approach. When flying a procedure without a glide path, such as an LNAV or LP approach, plan to fly the final approach segment just like other non-precision approaches using step-down altitudes and a minimum descent altitude. 2 miles from the final approach fix, select flaps to 50% to begin slowing to the final approach speed of 100 knots. Cross the final approach fix and fly the final approach segment using the proper non-precision approach techniques as described in the VOR approaches video in this series.
Okay, we're 500 to minimums, and we're just breaking out here.
Reaching the MDA, evaluate flight conditions, and make the decision to leave the MDA for a visual landing or to initiate a missed approach no later than the missed approach point. Your Garmin avionics provide an additional approach type that is not listed in your approach minimum section called LNAV plus V. LNAV plus V is an LNAV non-precision approach, but with an advisory glide path. The advisory glide path is represented on the PFD just as any other GPS glide path. It allows you to fly a more stabilized approach and eliminates the need for the traditional, less stable dive and drive approach technique. The glide path can be coupled to the autopilot. However, it is important to remember that as an advisory tool, following the glide path on an LNAV plus V doesn't necessarily guarantee optical clearance. If the advisory glide path inadvertently begins to take you below a step down or MDA, press the Alt-Hold button on the autopilot panel to immediately capture your current altitude. Then re-establish the minimum altitude appropriate for your position on the approach, and fly the rest of the approach using traditional dive and drive methods to minimize the risk of any confusion with altitude control. When following the advisory glide path under normal conditions, if you reach your MDA and do not meet the criteria to descend below it, initiate a missed approach at that time. Since the glide path will put you in a normal position to land, it is unnecessary to remain at the MDA until the missed approach point. Remember, an LNAV plus V procedure utilizes a glide path that should be followed in order to establish a planned and stable descent. But it is still a non-precision approach, and you must adhere to the MDA at all times.
The GPS technology installed in your Cirrus is designed to reduce your workload while flying instrument approaches as a single pilot. Your Cirrus will allow you to utilize a wide range of GPS approaches and minimums at many airports, increasing your operating effectiveness during IMC flight. Mastering GPS approach procedures will greatly increase your ability to reach the desired destination more confidently and safely.
The ILS is one of the most common instrument approach procedures in use today. Therefore, you must maintain a high level of proficiency in order to fly ILS approaches safely. Hi, I'm Keith Smith, a flight training quality specialist here at Cirrus. In this lesson, we'll review the ILS instrument approach as flown in your airplane. The Instrument Landing System, or ILS, is a true original. In constant operation since World War II, the ILS represents the first radio-based precision guidance system for pilots flying through inclement weather.
Instrument approaches are standard procedure nowadays through the magic of radio.
As a testament to the system's accuracy and reliability, the ILS is still in widespread use today. Slowly, ILS approaches will transition to a more supportive role as GPS-based precision approaches become more and more prevalent. Nonetheless, ILS approaches will continue to serve an important function within the IFR system, and the procedural skills required to fly an ILS will lay the foundation for pilots learning to fly precision GPS approaches. So in this video, let's focus on the ILS approach and walk through precision approach procedures, taking them step by step. An ILS provides the pilot with precise lateral and vertical guidance as well as range information via marker beacons and GPS. Visual landing guidance is provided through the use of different approach lighting configurations, runway centerline, and touchdown zone lighting and vertical indicators such as PAPIs or VASIs. On the PFD, lateral localizer guidance is represented by a green CDI needle, and vertical glide slope guidance is indicated by a green diamond just to the left of the altimeter.
You will fly the final approach course with respect to the information provided by the localizer and glide slope down to the decision altitude and visibility minima listed in the minimum section of your approach chart. The decision altitude is the altitude at which the pilot must decide whether to continue the approach to a landing or execute a missed approach.
Typically, this altitude will coincide with 200 feet above the ground. Most ILS approaches will allow a minimum required visibility of 1/2 mile in order to continue to a landing. As you approach the destination airport of Duluth International, the ATIS is broadcasting ILS runway 27 in use. They also state that the radar is out of service and vectors are unavailable. Upon checking in, ATC tells you to expect direct ANDO shortly. Loading the ILS for 27 via ANDO. Complete the descent checklist and brief the approach. Verify the correct ILS frequency has been tuned, and remember that it likely will not be identified until within the ILS coverage limits. Upon receiving your first ATC vector, or in this case, once ATC clears you to the initial approach fix, activate the approach. In this scenario, you'll then proceed direct ANDO, the initial approach fix, and begin slowing to 120 knots. Tracking the GPS, cross ANDO and turn outbound. The autopilot, while in nav mode using the GPS signal, will automatically navigate the procedure turn by sequencing you through each published turn found on the instrument approach plate. The navigation status section and pathway boxes provide added situational awareness while in the procedure turn. During the procedure turn, the CDI will depict the position of the final approach course. It's not until you proceed inbound on the turn that the CDI will switch to depict the inbound course.
Cirrus 123 Charlie Delta, cleared ILS runway 27 approach.
Once clear for the approach, arm approach mode by pressing the approach button on the autopilot. This will arm loc and glide slope modes. As you complete the procedure turn and are flying inbound to the final approach fix, the CDI needle will auto-switch from GPS magenta needles to loc mode or green needles. Begin to track the localizer inbound and complete the before landing checklist.
Establishing the final approach course on a vectored approach is slightly different. Notably, the CDI needle will immediately switch from GPS to localizer mode when you activate the approach via vectors. Then, to join the final approach course, you must simply rotate your heading bug to match the final intercept vector cleared by ATC and arm the localizer and glide slope by pressing the APR button on the autopilot panel. As the localizer comes alive, the autopilot will automatically switch from heading to approach mode and capture the final approach course. In either case, as you continue inbound and the glide slope comes alive, meaning the green diamond is fully visible, begin slowing to the final approach speed of 100 knots. To decelerate, verify you are within 50% flap speed limits and simply select flaps to 50%, allowing the added drag to slow you down while power is only slightly adjusted. As you are now established at your proper altitude prior to glide slope intercept, bug the appropriate missed approach altitude. In this case, 4,500 feet for the published missed approach.
When hand flying, begin a smooth and seamless final descent by timing your control inputs so that you are reducing power to the recommended setting and are pitching forward just as the green glide slope diamond centers on your glide slope indicator. If coupled to the autopilot, time a smooth power reduction to meet the recommended power setting as the glide slope annunciation turns from white to green in your status box during glide slope capture.
For more precise flying and increased situational awareness, keep the pathway boxes and flight path marker in your scan to ensure that your predicted flight path projects right down the middle of the pathway boxes. In this situation, the boxes will mimic your ILS course by showing a descending stack of boxes, which decrease in size as the course becomes more sensitive. The synthetic vision and pathways provide an amazingly accurate spatial picture of the approach course and works great to supplement the primary information you are receiving from your CDI and glide slope indicator.
Keep your instrument scan going, and if hand flying the course, make small bank, pitch, and power changes to adjust your flight path. Remember, as you approach the runway, the glide slope and localizer will become more sensitive. Therefore, focus to establish a controlled and stabilized descent so that the rest of the approach only requires small corrections as the course becomes more sensitive.
During the descent, make altitude callouts at 1,000,
1,000 feet to minimums,
500
feet to minimums,
and 100 feet
or 100 feet to minimums
above the decision altitude. Upon reaching the decision altitude, glance forward through the windscreen and decide whether or not you meet the required criteria for a continued descent below the DA. If you decide that you meet the criteria, disconnect the autopilot by pressing the autopilot disconnect button on the yoke and proceed to a normal visual landing using the approach lighting system to ease your visual transition and to provide visual descent guidance. If, however, you reach the DA and any of the descent criteria are not met,
minimums,
initiate a missed approach. When When it comes to precision approaches in your Cirrus, the skill set and procedural steps required to fly an ILS approach are easily transferable to an LPV approach, as both allow for instrument descents to very low minimums. However, while planning a flight to an airport that is completely socked in, remember that just because the minimums for the approach suggest you can make it, doesn't necessarily mean you should go. That go, no-go decision will be based on your proficiency with ILS approaches, your established personal IFR minimums, and your experience in aeronautical decision-making. With practice, you'll find an ILS approach to be one of the most useful tools for helping you reach your destination safely.
This was ILS, Instrument Landing System. ILS brought us straight and true directly toward the field.
It isn't every day that you'll execute a missed approach in instrument conditions, but when you do, you need to be ready for it. Hi, I'm Keith Smith, a flight training quality specialist here at Cirrus. In this lesson, we'll cover the procedures and best practices for safely flying a missed approach in your Cirrus.
Think of the missed approach as the IFR equivalent of a go-around. It's designed to get you safely from the point of an aborted instrument approach back to a safe altitude and course where you have time to make a new plan. Unlike a visual go-around, however, the missed approach is an instrument maneuver. It is more complex and involves higher pilot workloads. For many instrument pilots, flying a missed approach can be a stressful experience, mainly because they just don't happen that often. Your Cirrus Perspective avionics are designed to assist you in making the missed approach flow seamlessly as you make that rapid mental shift from landing mode to go-around mode.
In this video, let's prepare. Let's break down the elements of flying a smooth and safe missed approach step by step.
The first step in understanding missed approaches is knowing how to minimize risk and assess your instrument proficiency. Before you depart for any airport, reported and forecast weather should always indicate that you can safely get in. So here's the published minimums for today's flight. During pre-flight planning, as you are making that go, no-go decision, you should only ever look at these minimums as legal minimums. They're as low as you can legally go, and as long as you have the right certifications, no one will stop you from attempting to get to those minimums. It's up to you, before the flight, to make a serious risk assessment and to separate yourself from the legal bare minimums and to evaluate your own personal minimums based on your experience, proficiency, and comfort level when flying hard IFR in your airplane. Reviewing the Cirrus Instrument Flight Guidelines chart in Section 2 of the FOM, let's say you score as an average pilot, the blue square, in the Envelope of Safety IFR Minimums Guidance. You should make these additions to the published minimums to generate your personal minimums. If the forecasted weather won't accommodate your personal minimums, consider planning the flight for a different airport or simply delay until conditions improve. As you fly the approach, understand that any number of factors could cause you to execute a missed approach. Even things like a navigation equipment failure or even a vehicle on the runway. Most commonly, however, a missed approach must be executed anytime the approach becomes unstable. Anytime you can't establish a visual contact with the runway at the missed approach point or DA, if you lose visual runway contact during a circling maneuver, or anytime ATC requests that you go around. In any case, the missed approach must be initiated no later than the arrival at the decision altitude, or DA, on an approach with vertical guidance, or the missed approach point on an approach without vertical guidance. On approaches with vertical guidance, the point where you must decide whether or not to execute a missed approach is the decision altitude, or DA. The DA is not a hard deck. It's where you must make a decision to land or go missed, but it's designed to allow you to slip slightly below as you initiate the missed approach after making the decision.
As you reach the DA, look up. It's time to decide. In order to continue the landing, you must meet all the following requirements.
1. You must be in a continuous position to make a descent to landing on the intended runway at a normal descent rate and using normal maneuvering. Consider this your continued stabilized approach. 2. You must have the flight visibility required by the published minimums on your approach chart. And 3. You must have at least one of these 10 runway visual references in sight. If upon reaching the DA, or even at any point after the DA, you decide that any of these 3 requirements are not met, you must execute a missed approach immediately.
Minimums.
Minimums. Runway environment is not in sight. We're going to go missed approach.
When flying approaches without vertical guidance, there is no specific decision point, though you must adhere to a minimum descent altitude, or MDA. The 3 requirements for descending below the MDA are exactly the same as the requirements for continuing descent at the DA, but the decision-making process changes slightly.
As you level off at the MDA, look up. Do you meet the 3 requirements? If not, continue at the MDA and monitor your flight conditions until reaching the missed approach point, or VDP.
Many approaches without vertical guidance will depict a visual descent point, or VDP. This is simply a calculated planning point. It's a location that has been determined to allow a normal descent from the MDA to the runway. If you fly past the VDP and are still at the MDA, any further attempt to descend to make a landing will most likely force you into an unstable condition, descending at an excessive rate. When you decide to go missed, follow the exact procedure as published, unless otherwise instructed by ATC. The initial steps involved with flying the missed approach are nearly identical to those steps involved with a normal go-around, but with one key difference.
As you apply full power to initiate the missed, you can now also simultaneously press the go-around button underneath the throttle handle. Pressing this button activates the flight director into go-around, or GA mode.
The command bars will orient to a wings level, pitch-up attitude of 7 degrees, and the CDI on the HSI will change to GPS as the nav source, providing course guidance for the published missed approach procedure. If the autopilot is coupled during the missed approach, the go-around mode will allow for an uninterrupted autopilot coupled transition. Once you've reached a stabilized climb, a safe airspeed, and flaps have been retracted, either press nav on the autopilot panel to track the published missed approach route, or press heading to track the assigned ATC vector. Press indicated airspeed to set and establish the proper climb speed. Looking at the Duluth ILS runway 27 approach chart, the autopilot will climb straight and automatically initiate a turn to 060 degrees upon passing 3,000 feet. It will then level off at your bugged altitude of 4,500 feet the missed approach altitude. If, during the missed approach, ATC initiates vectors and clears you to climb and maintain a different missed approach altitude, simply update the heading and altitude bugs to comply with the clearance. As soon as practical, notify ATC that you've initiated a missed approach and complete the climb checklist.
And Tower, Cirrus 990 Hotel is going missed.
Cirrus 0 Hotel, contact Minneapolis departure, see ya.
Go to departure 0 Hotel.
Proceed on the published missed procedure until reaching the holding fix at the published altitude or, if applicable, follow ATC instructions. Approaching the hold, a recommended hold entry will flash in the PFD status bar. The to from flag will flip to indicate holding fixed passage, and GPS waypoint sequencing will be suspended to allow for indefinite hold duration. As you are holding, report to ATC that you are established in the hold.
Duluth departure, Cirrus 422 Alpha Kilo is established in the hold at 4,500.
And evaluate your overall situation. It's time to come up with a new plan. Factors such as weather, fuel on board, and runway conditions will affect your decision to try the approach again, select a different approach, or to proceed to an alternate airport. Once you've made a decision, advise ATC of your intentions and proceed with your plan.
Any pilot flying an instrument approach should be prepared to go missed at any time. Use the Cirrus Perspective avionics to help ease your stress and minimize cockpit workloads as you transition to the missed approach. With proper planning, most instrument approaches will end with a safe, uneventful landing. Still, there will be times when going missed is your only option. So be ready.
Minimums.
All right, we're at minimums. Runway environment's on site. We're going missed.